Hey guys, this is video 1.7 on counting significant figures. This is something that's probably going to be brand new to every one of you. And it could be something that takes you a little bit to get. So definitely make sure you pause when you need to, ask questions, do lots of practice, because these are things that are not going to go away. We're going to be using them all year long. So we've talked already about measurements and how they differ in the world of chemistry because they have built-in uncertainty, and that's where sig figs come in. This is a method for handling uncertainty in all measurements. Okay? So why these are important is because they let you know when you look at a number, like a measurement, it lets you know just how precise or accurate that tool was that you used, okay? So the reason we have uncertainty is that it arises due to the fact that we have different equipment with different degrees of accuracy, like I just said, okay? Significant figures are associated with measured values. So every single measurement has sig figs related to it. All right, exact numbers do not count when determining sig figs. So atomic mass on the periodic table would be an example of that. That's an exact number. Conversions, 1 inch equals 2.54 centimeters. So when we get into conversions here in a video or two, we won't worry about it. So it really comes back to just the numbers that have been measured, okay? So for example, we're going to do a lab on this if you haven't done it already. Reading a ruler, okay? So when we take a look, right, where this arrow is, we got to figure out, well, what does that measure when we look at it? Okay, we know that the object is more than 2, but it's definitely less than 3 when we look at that. So it's somewhere in between 2 and 3. So we know for sure that the object is more than, when we take a look deeper, okay, so 2 and 3 are kind of our big numbers, but then we can break it down into tenths, whether this is inches or centimeters, that doesn't matter at this point. We know that if you count 1, 2, 3, 4, 5, 6, 7, we know that it's more than the 8th one, but it's also less than 9. So 0.8 and 0.9, when we take a look at it in terms of tenths. So we would then, when we report this, we would want to estimate one past that. So we know that it's not 0.8, it's not 0.9, it's somewhere in between. We would then go to the hundredths place. So we would estimate the length to 0.01. Okay? If I went too fast or anything, pause, kind of go back, take a look at it, call me over. But I hope that you all have done measurements before. I hope you all can see that. Okay, it's somewhere like if we were to estimate that, I would say maybe 2.81. You might think it's 2.83 or 2.85. Guys, all of those would be considered correct because that last digit is the one that's estimated. And this is where the uncertainty comes in because my eye might see it as one thing and yours might see it as another. Okay, so this is why significant figures play a big role, okay? It tells us the uncertainty. We know that all three of those numbers are really, really close, right? They're not too far off. When you get to the hundredths place, they're pretty close. Now, if I said 2 centimeters and you said 4 centimeters, that would be a huge difference, okay? So that's in terms of like reading a ruler. Okay, we kind of see where it falls in between the lines. Graduated cylinders are very similar. However, there's one piece that we've got to take a look at. Again, something that you guys have all done probably before. All right, when we read the line, the water level, we have to read from the bottom of this thing called the meniscus. Okay, the meniscus is that curve on the liquid. Okay, that's in it. And that's due to, attractive forces between the liquid and the container itself. Okay, we're not going to get into that right now. But we got to make sure we read from the bottom. But same idea, right? You're going to look and see, okay, what's my scale? So this would be 20 down here, 30 at the top, 25. So this is 25, 26. So it's bigger than 27, but less than 28. Now, does this go any further than, just the ones place? No. So we're going to estimate one past our scale. So our scale goes to the ones place. We're estimating to the hundredths. So I'm going to say 27.5. You could very well say 27.4 or 27.6. All of those would be acceptable, okay? So there's going to be what we call an acceptable range. Okay, so even the Regents is written like this, that they will give you a range, and it's got to be close. Do your best with it, okay? Because remember, it's an estimate. Again, this shouldn't be anything groundbreaking or brand new, okay? We're going to get into that stuff here in a little bit. So what I want you guys to do is to pause the video right now, and then I want you to go through and answer all 6 of these and estimate it. So do that now. So as I go through and write the answers here, you're going to see me write this symbol, guys. Remember, this means about. Okay, so if you're close to the number I have, great. If you want me to come over and check it, raise your hand. I'll be more than happy to do so. So in A, you should have about 56.0 milliliters. If you wrote 56 on the dot, you would be incorrect because the lines in our scale represent, they read to the ones place. You need to estimate 1 past whatever the scale says. Okay, so I'm going to kind of write this as a rule of thumb up here. Estimate 1 digit past the scale. Okay, estimate 1 digit past the scale, and that's something that I will be looking for throughout the year. All right, B, you should have about 4.35 milliliters. You should be to 2 decimal places because each line represents 0.1. C, you should have about 23.5 milliliters. D, you should have about 16.8 milliliters. E, you should have about 76.0 milliliters. And the last one, you should have about 5.30 milliliters. So, ask questions in class. I know I kind of went through that quickly, but you can ask me. I'll be more than happy to help you. Let's continue on. Okay, so now when we talk about counting sig figs, how many numbers are significant in our measurement? Okay, so this might be confusing for you at first. This is where you can go back and rewatch. You can pause to kind of think through this. You can ask questions of your neighbor, of me. You can do some research online. This is where you guys kind of need to start. You may start kind of looking for those additional resources, okay? That's a good thing. That's how you do research. That's how you learn. You may not get it right away, and that's okay. Take your time and practice this. Step 1, determine if the decimal point is present. If it's present, think of P for present, okay? So why I have this map of the United States here, hopefully we all know, right, that the Pacific Ocean's on the west coast and the Atlantic's over here on the east. But guys, that P for present, just think of Pacific, okay? So if the decimal is present, we start from the left side counting, okay? You're going to begin from the correct side of the number. Atlantic is the right side, Pacific is the left side, okay? And you start counting at the first non-zero, okay? Then you're going to count all the way to the Atlantic, no exceptions. If your decimal is absent, hence A for absent, okay, you start your counting on the right side. And again, you're going to start at the first non-zero, and you're going to count all the way to the Pacific. Now, this probably means absolutely nothing to you guys right now. This is just a visual to show you what we're about to do. So let's jump in and do some practice here together. There's also some rules here that we can kind of keep track of. You don't have to memorize these. The more practice you do, the easier this is going to get. So, rule number 1, all non-zero numbers are significant. So when you see something that's 1 through 9, it's always going to be significant. So here's our example. 1, 2, 3, 4, 5, 6, 7, 8, 9. All of those numbers are significant. We have 9 sig figs in that number. If we take a look here at the second example, okay, scientific notation is easy. Whatever numbers you see in the mantissa, bam, that's how many you have. Count them up. We have 1, 2, 3. So we would have 3 sig figs here because they're all non-zeros. So far, so good, right? I hope. Number 2, zeros that are located between non-zero numbers are going to be significant as well. Okay? So if I take a look here, 40.7. Well, I have a decimal, so I'm going to start on my left side. I'm going to start counting sig figs at the first non-zero number. So that's going to be right here. And then I'm going to count until I run out, until all the numbers are gone. So that would be 1, 2, 3. I have 3 sig figs there. So because that 0 was in between two non-zero numbers, it's important. You guys pause the video and try this one. So 87,009 kilometers. No decimal, so I'm going to start, I'm going to start from the right side, and I'm going to count in my first non-zero. Well, that's the first one. So 1, 2, 3, 4, 5. I have 5 sig figs here. Number 3, for numbers less than 1, all zeros to the left of the first non-zero number are non-significant. Think about it. If we were to rewrite this number, guys, in scientific notation, those numbers right there are the only ones that are going to matter to us. We would write this as 9.587 times 10 to the minus third. Okay? So these numbers in our mantissa would be the ones that would be significant. All right? So again, when in doubt, rewrite your number in scientific notation if that helps you. Also, look to see, do I have a decimal? Absolutely. So I'm starting on the left-hand side. I'm going to start counting my first non-zero numbers. So if you have zeros at the beginning, cross them out. Okay? They're not going to be important. Then when you get to something that's non-zero, count until you run out. So we have 4 sig figs in that number. Okay? Take a look at the second example. Here we go. All right? Starting with the left-hand side. Oh, that's a 0, 0, 0. I'm not worrying about those. Bam, that's the only guy that matters for me here. Because again, I could rewrite that number as 9 times 10 to the minus fourth in terms of scientific notation. Okay, so when in doubt, guys, scientific notation is your best friend when it comes to counting sig figs. Number 4, zeros at the end of the number to the right of a decimal are significant. So here we go. Decimal point is present. I'm starting on the left-hand side, and I'm going to start counting at my first non-zero. So here we go. 1, 2. Oh, look, I have zeros. But once I've started my count, I continue to count. So 1, 2, 3, 4. There are 4 sig figs. Think back to our estimation, right? We're estimating this last number here. That means our measurement tool, our balance in this case, measures accurately to the 10th place. Okay, that tells you, hey, we got some pretty good accuracy there with our measurement tool. All right, the next one. Oh, decimal point, so I'm starting at the left. Here, this is a non-zero number, so I'm going to count all of these. So this would be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs. Okay? That tells us, hey, if this were actually true, this measurement tool right here would be super, super, super accurate. It'd be crazy amount, like super expensive. All right, number 5, zeros at the end of a whole number may be significant or not. If there's a decimal after the last zero, they're significant. If there's no decimal. So guys, again, you're looking for that decimal. If there's no decimal, just remember, we start on the right side. Okay? Nope, nope, nope. 1 sig fig is all I have here. Okay, because I didn't have a decimal. So basically, just to kind of summarize, guys, these rules are summarizing the whole idea of the Pacific and Atlantic. If one works better for you, great. Okay, find the way that works for you. It's going to take practice. Now if we take a look at this second number here, okay, we're starting from the left because there's a decimal point there. So that means I start my count here. Now these zeros are significant. So I have 4 sig figs there. Okay, this number, which one's more accurate of a number? This guy's more accurate because it's saying that, hey, we accurately measured to this. Our last number was the estimated one. Okay? Up here, since we have 1 sig fig, that's the estimate right there. Exact numbers have an infinite number of significant figures because these are conversion factors. So these are accurate. They're not measurements, okay? They're pieces that people have already looked at and confirmed, so we don't need to worry about that. Okay, so you always, when doing calculations, you go back to your original number, which we'll talk more about. So I want you guys to go through and practice this on your own. Ask questions. This is something that's going to be confused, guys. This may not be enough practice. You may want to do more. I've got plenty of practice in the extra practice binder, so make sure that you can master this piece before you move on to the next piece. All right, I'll see you in the next video.